We are starting with the topic of set notation, and along with it, we learn about these diagrams called Venn diagrams. Now, what exactly is set notation? Now, it's a way of arranging data. For example, if I talk about a set A and inside this curly bracket, these are the elements of A. For example, let's talk about numbers 1, 2, 3, and 4. There is another set B that is also 1, 2, 3, and 4. And there is a set C, which is simply 1, 2, and 3. Now, we see that these two sets are exactly the same. So we will say set A and set B are equal sets. When we look at C, we see that the C, all these three elements, they are part of A. All these three elements are also part of B because A and B are equal. So we will say C is a subset of A. I can also say C is a subset of B because A and B are equal. Now, not all elements between B and A are equal, which means that yes, C has 1, 2, and 3, A has 1, 2, and 3, but it does not have 4. So we will say C is a proper subset of A. The same goes for B. C is a proper subset of B. So we write this notation, a U acting sideways. Let me write it like this. And C is a subset, a proper subset of A. So this is written in these green alphabets, and this is the symbol. What about A and B? A and B are equal. So we will say A is an improper subset of B. So this is the symbol for improper subset. If two sets have exactly the same elements, what is inside? These are called the elements. So let me write it over here. These are elements of the set that makes up the set. Now, what else is there? Let's talk about union and intersection. Now, when we talk about union, that means take all without repetition. And intersection means the common, the overlapping region between two sets. Now, this overlapping region, this is in the context of Venn diagram. Over here, what's common between the two? Now, let me use some other sets. Let's say I'm using the symbol C for another set. C is 1, 2, 3, 4, and 5. There is a set D, which is 3, 4, 5, and 6. Now, first of all, the symbol for union is a U. The symbol for intersection is an inverted U. And this one was a sideway U. Okay, so it's all about the U's. Take all without repetition. So if I talk about C union D, let me use a highlighter. There is one that's not common. The common is 3. The common is 4. The common is 5. And the rest are uncommon. So let me first write the intersection C intersection D. That is 3, 4, 5, and it's written in these curly brackets. What about C union D? That is take all without repetition, which means I'll take 1, I'll take 2, I'll take 3, 4, 5. These are already taken. So I won't write it twice and then 6. So this is 1, 2, 3, 4, 5, 6. These are the elements of C union D. So what's the definition? Take all without repetition. What is the definition? The common elements, or in terms of Venn diagram, we will say that it's the overlapping region. Now, let me take the same two things, which is right over here, that is C and D, and let me copy it and write it over here. Okay. Now let me introduce another set, which is E, and it has the number 7, 8, and 9. Now, does E and D have anything in common? Nothing at all. Does C and E have anything in common? Nothing at all. So if I talk about C intersection, my bad, this is C intersection E. So I'll say there is nothing on the inside. This is called a null set because there is nothing on the inside. It's technically a zero. Well, zero is a digit we are talking about, so we just leave it empty. What about D intersection E? That is also a null set. So this one is a null set. This one is a null set. There is nothing in common. Nothing inside, nothing in common. Now, what else needs to be explained? Let's talk about universal set. This E is the universal set. For example, if I talk about that this E is the set of all numbers, all integers between 1 and 20 inclusive. This could have been written in a different manner also, and we will see in the past paper questions also. E is an element X such that X lies between 1 and 20 and X is an integer, something like this. So two different ways of stating the same truth. Let's say there is a set A, and A is such that A is part of this universal set, and we will say A is a prime number. What about B? B is X is such that it's an even number. What about set C? C is an element of X, something like that, such that it's an odd number. So now, if universal set is 1 till 20, that's 1, 2, 3, all the way till 20, then what are the prime numbers? The prime numbers will start from 2. This is 2, 3, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. So this is A. What about B? Even numbers. 0 is not there because it's starting from 1. 2, 4, 6, 8, all the way till 20. What about odd numbers? 1, 3, 5, 7, all the way till 19. So now, whatever the sets that we are dealing with, they are restricted till this. So that's what the universal set is. And let me add one more page over here. And we can talk about something like this. Let me write another set. Q is 10, 11, 12, 13, 14. And R is 13, 14, 15. And let's play with two of them. If I write this N, that is the number of elements. So number of elements in Q. How many are there in Q? 1, 2, 3, 4, 5. That is 5. Number of elements in R. Number of elements in R. That is 3. Let's evaluate Q intersection R, Q union R, first of all. And then let me also write Q intersection R. Doesn't make a difference which one I'm doing first. What's common between the two? We have 13, we have 14. These two are the common ones. So let me write the common one first. That is 13 and 14. So this is 13, this is 14. And what about the union? Take all without repetition. So this is 5 and this is 1. That is 6, 10, 11, 12, 13, 14, and 15. So that is 10, 11, 12, 13, 14, 15. Now, observe one thing. There are 5 elements over here. There are 3 elements over here. 5 plus 3 is 8. How many elements are there in the union? 1, 2, 3, 4, 5, 6. Let me write it. Number of elements in Q union R is 6. Number of elements in Q intersection R is 2. Now let's add up the result. Let's try to generalize something. 5 plus 3 is 8. Union and intersection also adds up to 8. So therefore, I can write number of elements in Q plus number of elements in R, that equals to number of elements in the union plus number of elements in the intersection. Provided, we are just using this number. There is no numbers from the outside. And naturally, we are using these numbers. So we can say the sum of the elements in each set individually is equal to the sum of the union and the sum of the intersection. So that's an important result. Maybe sometime we will be using it. So this is something very important. Now, what else can we show? If I draw a box, and this box can represent a universal set, and let me just go one by one. So let me first copy this thing, and let me paste it over here. Let me draw another diagram, and let me paste it over here like this. And yes, there is one thing that needs to be shown. Hold for a second. That is this. And one other one. No, I'm not interested in this. I'm interested in this thing. Okay. And let me bring these two closer. Okay, something like this. Now let's say this diagram is known as Venn diagram. This is for diagrammatic representation of sets. For example, this is A. This is universal set. Let's say the universal set contains the element 1, 2, 3, and 4. And set A contains the elements 1 and 2. So we will write 1 and 2 will go inside A, and what is part of the universal set, but not part of A, that will be written on the outside. So that is these two. That is 3, that is 4. So 3 and 4 are written on the outside. What's not in A, but in the universal set? So what's not in set A, but is part of universal set? That is this. This is known as A complement. So therefore, I'll write A complement is 3 and 4. That's the basic idea. What else is there? Let me write a set C. Let me write a set D. Let me write another universal set. So let's say universal set is alphabets. We are using C and D. So let me just erase this. Hold for a second. Let me erase C. Let me erase D. Let me write this thing as A and B or Q and R. That's better. So let me write this thing as Q, this thing as R. And let me use A, B, C, D, E. So let's say set Q is A and B. Set R is C and D. And there is no other set. So therefore, Q has A and B. R has C and D. E goes on the outside. And there is nothing in common between these two. So if I write Q intersection R, I'll say it's a null set because there is nothing in common. If the intersection is a null set, we call it a disjoint set. And we can also write this thing as number of elements in Q intersection R is 0. That's another way of explaining a null set. There is nothing in common between them. So these are two separate parts. And what else can I show? I can show that there is K, set L, universal set. Let me write 1, let me write 2, let me write 3, let me write 4. And this will be the basis of what I'll be doing next. So universal set is 1, 2, 3, 4. And set K is 1, 2. Set L is 3, 4. No, not 3, 4, 2, 3. And yes, there is something in common. That is 2. And now let's talk about these. And this is what we are starting with the shading that is done on the Venn diagram. Now, in order to do effective shading, let's first focus on the calculation. So now I'll be using some of these diagrams. So just hold for a second. Let me drink some water and then I'll be right back. Now, what needs to be done is that let's do some basic calculation first. Let me take the universal set as 1, 2, 3, and 4. Just for simplicity, I'm not putting in the comma signs. I just want some cleanliness. Universal set A, let's take it as 1, 2. Universal set B, sorry, not universal set. Set A is 1, 2. Set B is 3, 4. A complement is what's not in A but in the universal set. So 1 and 2 is part of A, 3 and 4 is not. So 3, 4 will go over here. One more thing. I just made a small mistake. Hold for a second. I'm just changing some numbers. So first of all, this is 2 and this is 3. And let me just put the comma sign because I'm doing it anyway. And A complement is 3, 4. B complement is 1, 4. Okay. Let me write A intersection B. Let me write down all the possibilities first. Let me write A union B. Let me write A complement intersection B complement. Let me write A complement union B complement. And then I'll proceed further on. So A intersection B, what's common? A intersection B, 2 is common. So let me write a 2 over here. A union B, what's there? In A union B, we have, let me use a thinner highlighter. That is this thing. That is 1, 2, 2, and 3. But 2 is written once. That's A union B. So let me first fill it up. So this is 1, 2, and 3. And a little bit of purple dots over here. What is A complement intersection B complement? A complement and B complement, what's the intersection? The intersection is 4. So A complement intersection B complement, that is 4 over here, and that's 4 over here. What about A complement union B complement? So now A complement union B complement, that is this 3 and this 4 and this 4 and this 1. So this is 3, 4, 1. So therefore, the common is 4, and this thing is 3, 4, 1 or 1, 3, 4. Okay. Now, this is the calculation that I've done, and I have 4 diagrams. Let me just place them a little bit better, all the way over here with some gaps, and a little bit over here, and a little bit over here. So now, first of all, I'll use a black marker. I'll write A, I'll write B, and I'm interested in shading A intersection B. Now we can see that A intersection B is 2 over here. So even before that, let me fill this up. This is 1, 2, 3, and 4. Universal set. This is A, this is B, this is 1, 2, 3, and 4. This is A, this is B, this is universal set. This is 1, 2, 3, and 4. This is universal set. This is A, this is B, this is 1, 2, 3, and 4. Because 4 is on the outside. It's not part of A, it's not part of B. Everyone clear on this? Let me check my WhatsApp because I did not do so. Okay. Yes, it's clear before. Okay, now let's get started. So now A intersection B. A intersection B is this thing. Let me just erase this thing, so that there is no too much shading. Okay. So I've removed all the excess things like this, and it looks much clearer. So now A intersection B is this thing. That's right over here, which is 2. So that's this thing. So let me just shade this much of the region. Let me choose orange color. That will be easier to see. And let me make it more thinner. Okay. So this is the region that is for A intersection B. That's the region. Let me just erase the extra stuff that's right over here, and then something like this. Okay. Now that's the answer for this part. Now it would be working. The question would be coming both ways. Once you are getting the hang of it about shading, later on I can give you the shading and you have to judge what is the equation that relates the two. So this is for intersection. Now, what about union? That's 1, 2, 3. That's 1, 2, and 3. That's everything. So now I'll shade it. For this, I'll be shading this thing and this thing and this thing. So everything will be shaded like this. Okay. So that is A union B. So this is A union B. Okay. What else is there? What about this thing? A intersection, A complement, this one, A complement, intersection B complement. That is 4. So that is this 4 over here. So now I'll be shading on the outside. So let me use a green marker. And I am shading this thing on the outside. So let me choose something smaller. And this thing and this thing. Okay, it's just a rough shading. Just to show you that this thing is on the outside, this is outside, and then something like this. So this is representing 4. That is A complement, intersection B complement. So this is A complement, intersection B complement. And let me do one thing more. That is, let me take this thing, let me copy this. And let me write it over here. And let me do one more thing. What is, I'm relating with this one. What is A intersection B? The whole thing complement. Now, A intersection B is 2. What is A intersection B whole complement? Except for 2, this is this and this and this. So, except for 2, we have everything. So, one more thing that I've done. This is 1. This is 3. This is 4. Let me focus on A union B. So now I'm interested in A union B, the whole thing complement. That's 1, 2, 3. So except for 1, 2, 3, what do I have? I have 4. Now, do you see the commonality? A complement intersection B complement is 4. A union B, the whole thing complement is also 4. So therefore, let me shade this region, which is right over here. So therefore, this thing and this thing is exactly the same. So now this 4 is also A union B whole complement. A union B, the whole thing complement. So let me just erase something from here so that there is no confusion. And from here, and then a common like this. Now, what do you observe? You observe that A complement intersection B complement. This is difficult to sketch. That's the same thing as A union B, the whole thing complement. So it's something very, very useful. So let me write it. So the result that you get is that A complement intersection B complement is the same thing as A union B, the whole thing complement. Okay, that's the first thing. Now, let me take these results on the next page. And I'll be working a bit more with this. And I think some of you might have observed what is the next step that I'll be taking. So let me write it over here. Now, let me again write over here. This is universal set. This is A. This is B. This is universal set. This is A. This is B. Let me fill this all up. So this is A. This is B. And universal set on the outside. And this is A. This is B. And this is 1, 2, 3, and 4. 1, 2, 3, and 4. This is 1, 2, 3, and 4. This is 1, 2, 3, and 4. Okay. Now, I talked about A complement intersection B complement. I talked about A union B whole complement. So I need to copy this thing also. Okay, so let's copy this and let's put it over here. Let me now label this thing. That is A complement union B complement. So I think the numbers are not that much. The boxes, I need to arrange them a little bit better. Okay, that goes like this. This goes like this. Okay, now first of all, I'm interested in A complement union B complement. This thing. A complement union B complement. That's 1, 3, 4. 1, 3, 4. So this is A complement. Union B complement is this thing. That's right over here. That's right over here. And that's also this thing. So this whole thing will be shaded. I'm just shading part of it. That whole thing is there. So let me write it over here. That is A complement, union B complement. And is there anything which is exactly the same? That's this one. That is this thing, which is A intersection B whole complement. So A intersection B whole complement, that is exactly the same thing. A intersection B, the whole thing complement. So again, let me shade it and with a different color. So therefore, that is this thing. That is this thing over here. Now you don't have to actually shade it in color. It's basically you shade it with lines. So since I have the liberty of using a color, so I'm using the colors. So now again, what do you observe? These two are exactly the same. So therefore, let me copy this thing from here and let it remain also over here. And let me write it over here. So after this result, the next important result that I obtain is this. That is A complement union B complement. That is A intersection B, the whole thing complement. Double check. A complement union B complement. A complement union B complement. That's A intersection B, the whole thing complement. Let's just pause for Azan. So now this is the observation that we make. So next time, if I ask you to draw this and shade this, you will do this instead because this is easier. And if I ask you to do this, you will draw this. Now, what other possibilities are there? What if I have something like A union B complement, or I have something like A intersection B complement? Now, B complement is what? So let me go back all the way up. That's this thing. So let me just copy this part of the thing. I'll be using it on the next page. So somewhere over here. Let me simplify this. Okay. Now this is on the side. And if I am interested in this thing, let me just pull it down. Let me pull it down. Let me make it up and a little bit bigger. Okay, now, if I am interested in A union B complement, so this is A, this is B complement. What's common between them? What's union between them? So first the common, 1, 2, 1, 4. The common is 1. What's the union between them? That is 1, 2, 1, 4. So the union is the orange and the green, basically the green. So let me 1, 2, 1, 4. So 1, 1, 1, 2, 4. So this is 1. And this also 2 is included. So this 1, 2. And this thing on the outside, that is 4. So this thing is over here. That is the union. Let me write it. So the union is 1, 2, and 4. And what is common? That's the orange one, which is simply 1. So A intersection B complement is simply 1. So that's the orange one. That is over here. Now we will also understand this in the context of word problems. Now, first of all, over here, let me write this. This is A intersection B complement, and this is A union B complement. Now, what I'll do is that I'll just take these diagrams and I'll paste it over here one by one. So now enough of the calculation. Let's focus on each one of them. And then what I'll do is that, let me first just copy this whole thing. So this whole line that I'm copying, I'll write down what it means in words. So first, if, the wrong thing. So I've copied it. Okay, and I've added a page over here. Let me add a more page. So first of all, let me paste it. And this thing needs to be copied. Okay, now let's relate this with some words. So, Venn diagram, and what is the interpretation in words. Let's say 1, 2, 3, 4. These are the school ID of 4 students. Student 1, student 2, student 3, student 4. And A stands for the subject. Let's say A stands for physics. And B stands for chemistry. And the universal set is a class or section of 4 students with the following ID 1, 2, 3, 4. Now, for each, I'll write down a statement. So let me just push this a little bit below so that I have more spaces to write. Okay, let me just push this a little bit to the top. Okay. Now, for each, if I write a statement, first of all, the statement for the first one, and then a statement for this one, and then a statement for this, and then a statement for this, and the same thing will continue to the next page. Now, if I talk about A intersection B, so A is physics and B is chemistry. So these are students taking both subjects. Student or students. So there is only one student. There is only one student taking both subject, and that has a school ID of 2. As simple as this. Now, what is this? 1, 2, 3. So these are students taking either physics or chemistry or both. So physics people are 1 and 2. Chemistry people are 2 and 3. The number 2 student is taking both subjects. So it's either A or B or both. So now let me write one more statement. That is, when we talk about intersection, this is common. So both A and B, that is what intersection is all about. And this is also used in further probability. If we talk about the union, it means either A or B or both. That's what the meaning of union is. Okay. So now, what about this thing? Who is this person? He's neither taking A nor B. So we will say neither taking the subject physics nor chemistry. So there is only one student, again over here, only one student with ID, that is ID number 4. And that is the same thing over here. That's A union B whole complement. So this is the same as above. What else is there? Let me write 4 more statements. That is A complement union B complement. Now it's everyone who's taking only physics, only chemistry, none. So except for both, this includes everyone. Everyone accepts the student taking both physics and chemistry. And this is exactly the same as above. Now remember, these two things are the same. This and this are the same. A intersection B whole complement. Now A intersection B is both. So besides both is everyone except the student taking both physics and chemistry. Okay. Also remember, A union B whole complement is A intersection B complement. This is easier to interpret. A union B is taking everyone, either A or B or both, except for that is this person. What is this? This is taking A only. So A intersection B complement is taking A only. So A is studying physics. It does not include person who's taking both subjects. And what is A union B complement? This is everyone except for the student taking chemistry only. Now B is chemistry, A is physics. Got the idea? So now this was the idea behind the shading. Let's move to 3 circles. Now again, this is the universal set. Let me fill this up. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. And let me fill up in the same order. So this is 1, 2, 3, 4, 5, 6, 7, and 8. And this is 1, 2, 3, 4, 5, 6, 7, and 8. We should always have something on the outside because that needs to be included. Now, let me just copy this because the other one, let me add this thing. Hold for a second. This is 8 over here. So let me pull it to the side. This is 8, this is 8, this is 8. Hold for a second. So this 8 goes over here, over here, over here. This is A, this is B, this is C. This is A, this is B, this is C. And also over here, this is A, and this is B, and this is C. So now I need to add a page first. Hold for a second. So let me first copy this thing, everything on this page. Copy, add a page. Okay. Now let me add a page before that. And let me write universal set as the orange thing. So universal set is 1, 2, 3, 4, 5, 6, 7, and 8. And then I have set A, and I'll write A complement right in front. So let me just erase this. Hold for a second. Let me write this as A and A complement over here. Let me write B and B complement over here. Let me write C and C complement over here. I'll be interested in A intersection B intersection C. I'll be interested in A union B union C. I'll be interested in A complement intersection B complement intersection C complement. And I'll be interested in, let me just shift this downstairs. So resize a bit. Okay. And no, this looks bad. So this is A intersection, a complement intersection B complement intersection C complement. A complement union B complement union C complement, and then there could be some more. So first of all, what is A? In red color, A is 1, 2, 3, 4. So A is 1, 2, 3, and 4. The blue color is used for B, that is 2, 3, 5, 6. So this is 2, 3, 5, and 6. What is C? C is 3, 4, 5, 7 in green color. 3 is 3, 4, 5, and 7. Okay, all good. Now let me write A complement. So A complement is also written in red. That is 5, 6, 7, and 8. B complement is 1, 2, 3 is there, 4, 5, 6 is there, 7, and 8. And then no. I don't need red color. I need blue color. So let me change the color. Okay. And what about the green one? 3, 4, 5, 7. So this is 1, 2, 3, 4. 5 is there, 6, 7 is there, and 8. So is this all good? All clear? Now, first of all, A and B and C, what is the common thing between all of them? 1, 2, 3, 4, 2, 3, 5, 6, 3, 4, 5, 6. The common thing is the 3. So this is 3 only. So let me write this as 3. What about the union? 1, 2, 3, 2, 3, 4, 5, 6, 3, 4, 5, 7. So it's everything except 8. So this is 1, 2, 3, 4, 5, 6, 7, everything except 8. Now that brings me, excuse me, let me push it down like this. That brings me to the idea that what is A intersection B intersection C, the whole thing complement? That is 1, 2, and hold for a second, I need space. So let me push it down over here all the way. So if I relate this thing with this, the whole thing complement, that would be except for 3. So 1, 2, except 3, 4, 5, 6, 7, and 8. If I link this over here, what should I write? I should first write A union B, hold for a second, A union B union C, the whole thing complement. And I think this is getting messed up over here. Now over here. Okay, let me erase this. So now if I'm talking about this stuff that is here, so this will be 1, 2, 3, 4, 5, 6, 7. What's left? That is 8 only. So let me erase this. Let's focus on this first. So we have a lot to focus on. Let's shade these 4. 1, 2, 3, and 4. So let's share in pairs. These 2, and then these 2. A intersection B intersection C, that's 3. So that's just the small one. That is right over here. That's in the middle. Okay. So this is, let me choose a purple color, and that is this thing. Let me make it smaller. That's this. So that is A intersection B intersection C. That whole thing, the common between all of them. Now let me also use words over here. A is physics, B is bio, and C is chemistry. So this is a student taking all 3 subjects. That is what is meant by A intersection B intersection C. And what about the other one? Let me choose A union B union C. So this is A union B union C. That is everything except for 8. So this is everything except for 8. So let me choose this thing. This is everything. That is this thing and this thing and this thing. This is everything except for 8. Let me draw lines like this. It will be more convenient. So this is everything, everyone taking all 3 subjects. So that is over here. Okay, now let me choose this. Let me go to a next page. I want 2 diagrams on the same page. So let me add a page over here. Let me add one more. Okay. Let me add these 2. Let me add a page over here. Okay. Now the first 2 things are done. Let me focus on this. Now it's A intersection B intersection C, the whole thing complement. That's also the same thing. That's not also the same thing. That's 1, 2, 4, 5, 6, 7, 8, except for this 3. Now, what does it mean? So, except for the 3, shade everything. So, let me choose this color. That is this and this and this, like this, like this, like this, and so on. Also shade this orange one, shade this orange one, shade this orange one, except for 3. So this is A intersection B intersection C, the whole thing complement. That means everyone, no, the 8 is also included, my bad. So let me also add the 8. So that's also included. Everyone except the person taking all 3 subjects. Okay, that thing is. So it's the purple shading as well as the orange shading. So let me just remove the orange shading. So if I remove, no, not the whole thing, cannot get any smaller than this. Okay, then there is no use. So basically it's this thing as well as this thing. So it's orange and this thing together. So everyone except the person taking all 3 subjects. What about over here? What is this? That's A union B union C, the whole thing complement. That's 8. And let me also paste each one of them alongside the shading that we have done. So that means in order to do effective shading, a little bit of the calculation is needed. So over here, to start with, that's the first thing. And let me copy this. Okay, that also goes on this page. That's over here. Okay, and this goes over here like this. Okay, and what else is there? Let me also copy this. I think this is obvious, but there is no harm in copying this. A intersection B intersection C. Copied it. And okay, the space is a little bit messy. So that is this thing. And over here is this thing. That is this one. Okay. And let me remove this thing because it's no more needed over here. So I've removed it. And now I'll be shading this one. So therefore, the shading is this. That is only 8. So therefore, we are shading this thing over here. So this is everyone. Sorry. the person not taking any of the subject, that is uh, A stands for physics, B stands for bio, or C. That means this person is not studying the three science subjects. Okay. So now this thing is there. Let me do some more examples, and you can understand the nature of this set notation, that this is like a chapter that feels difficult in the beginning. To some extent, yes, it is difficult. And let me add this page over here. Let me do some more calculation. Now, what other possibility can I make? Now, I did A, B, C, the intersection, A, B, C, the union, A complement, B complement, C complement, the intersection, and the union. What about a combination of these two with this? What about a combination of any of these two with this, or these two with this, something like that? So I think there are four possibilities that I can make. So let me just make two possibilities on each page because it looks better. So this is 2, and let me just write over here, that's this thing, that's 2 of them. And also over here, I think 2 are enough. And let me just copy this thing. And if there is something that's needed more, so I'll be having a page that I can work with. Just an extra page. Okay. So now, first of all, let me work things out. The first option that I can consider is that A intersection B union C complement and A intersection B intersection C complement. Let me focus on this. So A intersection B intersection C complement. Now, first of all, let me use the orange marker. And what's common between A and B? A and B, the common is the 2 and the 3. And now I'm unionizing it with what? I'm unionizing it with C complement. So either I can take a common, that common is 2, or I can take something like unionizing, that's 1 and 6 and 8. Okay, what does it mean? Basically, I'm taking 2, 3, and if I'm taking common with this, with C complement, the only thing common is 2. Okay, so this one is only 2. And A intersection B union C complement, so that is 2 and 3, and 2 is again there. So 2, 3 is there, 1 is there. So 1, 2, 3, 6, 8. So this is 1, 2, 3, 6, and 8. So this is what you get. Now let me copy this. Actually, I need both of them. So let me copy these both. And let me paste it over here. Let me just increase the space over here. And there it is. Now, first of all, I'm interested in shading only 2. So only 2, and this is an important shading that usually comes. That is only this over here. So what does it mean? A stands for physics. This is physics. This is bio. This is chemistry. That means a person who is taking only physics and bio, and that is it. So a person, a student, taking only A and B. So now only A and B, but not C. That means if I were to include C, it would be all these 3, right? So that would be A, B, and then C would be this. And but not C. So just A and B. So this is just physics and bio only. That's another way of writing it. And who are these people? 1, 2, 3, 6, 8. So this is, let me shade this. This is 1, Let me use this. This is 1, this is 2, this is 3, this is 6, and this is on the outside, that is 8. So this is 8, 1, 2, 1, 2, 3, 6. So that is this thing. It's difficult to say it in words. Physics people are there, bio people are there, a person taking all 3 subjects, a person taking none of these subjects, but who is not there? Everyone except a person taking A and B, a person taking B and C, a person taking C only. So this is difficult to write in words. It's too much to write. Now, I think these are the different scenarios that we can come across, and anything that is exceptional, we can write it out. For example, if we were to write A intersection B union C complement, we can have A complement intersection B complement unionizing with C, A complement intersection B complement intersecting with C, and such possibilities can be done if we have everything in place. Whenever we are stuck, we can plug in some numbers and understand that region. Always remember there has to be something on the outside. So I'll just stop over here. So that is the end of lecture 1 of set notation. In the next class, we will start with some past paper problems and some more word problems. Take care.